Good evening. Today we are going to deal with Rolle's theorem, and by the end of this class, we should be able to determine whether the function we are given is qualifies to be a Rolle's or not. Again, we should be able to know whether the function adheres to the conditions that are attached to Rolle's theorem. So once again, you have a function of x as you are given one here. Then you should know that that function f of a should be equal to f of b, and the function should be continuous at point a and b. And again, the last condition is that it should be differentiable at a closed interval a and b. Then let's check whether it adheres to this. Then you have to know that f prime of c should be equal to 0. If you differentiate the function at point C, uh, for us to say that it is a Rolle's, it means the derivative of c is 0. So once again, you have a function like this, and you are having a curve like this. So let's say this is the point A, and we have point B. So at this point, where you have tangent which is parallel to the chord A and B, it is the point that we say it is C. So here we have C. So once again, let's first confirm whether the function of A is equal to function of B. So once again, let's replace. This is your A, this is your B. So if you take x squared minus 5x plus 3, let's replace with 0. So it is 0 squared minus 5 into 0 plus 3, which is giving us 3. 5 squared minus 5 multiplied by 5 plus 3, it is 25 minus 25 is 0 plus 3, so you are getting this 3. So for the first time, it has accepted that one. Once again, it is continuous at the end point A and B, and it should be differentiable. It means you can differentiate this equation at the end point, at closed interval of A and B. At this point, you can differentiate. So once again, you know the derivative of that function of x. If you differentiate, it should give us 0 at point C. So the turning point of that equation is where we have the C. So once again, let's differentiate it is x squared minus 5x plus 3. So once again, you are getting it is 2x minus 5, and you are equating with 0. So what is that point C? What is that point C? That satisfies our equation for us to say it was Rolle's equation. So once again, you are getting it is 2x is equals to, now the 5 on the other side, then you are getting it is the value of x at that point, it is 2.5. So the C should lie between the given interval. Remember, 2.5 lies between 0 and 5. So it is true. So once again, you have to confirm whether it has agreed to all these conditions which are attached there, and you found that it is true. So that is all about the Rolle's theorem. Let's check example 2. It's about Rolle's theorem once again, and you are given a function of x, then you are given an interval which is between 0 and 2 pi. So we say the first condition, f of a should be equal to f of b at that interval for us to say that it is a Rolle's. So once again, you check if you take sine of 0, which is now the value of x, whether it should be equal to sine of 2 pi, which is now sine of 360. So sine of 0 and the sine of 360, they give us 0. Both of them give us 0. So once again, that one it is true. So once again, it should be differentiable. It should be differentiable at closed interval, which is 0 and 2 pi. What do you get when you differentiate a sine x? So once again, if you differentiate sine, you get cos. If you differentiate cos, you get negative sine. If you differentiate negative sine, you get negative cos. And it goes on, it goes on. So once again, we are differentiating this at the closed interval. So if we differentiate, then our function was like this. Now since it is for sine of x, it is going like this, it is going like this, it is going like this. So this is our 2 pi. Once again, you are able to see there are some points there, and this one is like pi, it is pi, and we have the turning points, and this one is pi over 2, and this one is 3 over 2 pi. So once again, when it is like this, let's check. If you differentiate sine, you are getting it is cos x. But we said the derivative of our function of x should be equal to 0. So what is the function of cos of x that gives us 0? So once again, you are able to see that it is cos of pi over 2 and cos of 3 pi over 2. So once again, these are the values of c that we are to look at. That satisfies our function for us to see that the first derivative of that one, c, should give us 0. So once again, you are able to see the 2 points. This is the tangent, which is parallel to our function, where you are getting it 0. So that was the second example. So kindly you can subscribe, like, and comment as I'm going to come up with more concepts. Yes, welcome.